Let's go ahead and start together. Hi, everybody. This will be the last time I talk to you directly. It's very impossible to see you. It's crazy. You would think I could just look up and see you, but there are lights all around, so I can't quite make you out. So, all that being said, I'm glad you're here. This will be a lot of fun. So, let me begin by apologizing for the name of this session. It is incredibly long and impressively vague. The fact that you're here at all is pretty impressive, to be honest, because what do you think is about to happen here? It's really hilarious. My name is Jerry Nixon. I work at Microsoft, so let's get that part out of the way. And I work on the SQL Server team. And so specifically, I am on the Data API Builder team, which is part of Developer Experiences, which means all of the tools and libraries that are specific to make and kind of reduce the friction for developers and make your life a little bit easier is all I work on. And so it's not necessarily the data engine that's my job. Now, the good part of that is it kind of allows me to use the skills that I have had all along. I've been a field engineer for a long time at Microsoft. And so I've worked with some of our largest customers, dealing with some of the biggest data engineering things. Let me just say it that way. All the nightmares that people have to go through, I've been able to manage those and kind of work through those in different ways. And I've sort of taken the average and brought it together to tell you about really what we see some of our larger customers going through, and also what we see some of our sort of medium-sized customers going through, and kind of giving you just a snapshot into their life of what it is that they are doing to manage their data, but also how their development teams, their engineering teams work to be able to manage all the schema drift and different problems that they have to kind of contend with. And so there are a lot of ways to approach this, and I'll approach this from the Microsoft way, but I will tell you that everything I'm about to say, there's some alternative, and many of you have already started to use those. So you're already using some other thing, and this isn't me saying that those are wrong. Actually, it's me saying those are right. Not using some of the tools and some of the things at your disposal is really how engineering teams get into trouble quickly. And so let me walk through the whole thing. Let me talk about me just for a second. It's one of my more favorite topics. So not just Data API Builder, but I'm also a big Star Trek fan. And I mean, I know nothing down against Star Wars. I absolutely love Star Wars as well, but not like I love Star Trek. So here I am. This is in New York City, and right here on the bridge. If you recognize this as the bridge of the NCC NCO1 dash, does anybody know? Yeah, well, all right. I forgive all of you in advance. It's the D. Well, I mean, it's incredible. But that's not all. I'm also a professor of computer science. I live in Colorado. I'm from America. I live in Colorado. And I'm a professor of computer science there as well. And so I talk about C# constantly. And so if you're a C# fan, then we are just built-in friends. It's terrific. And so as a field engineer, I was an evangelist for years. About 8 years, I was a developer evangelist for Microsoft as well, specifically talking about XAML. So back in the day when XAML had its golden age, I was the evangelist. That was the reason we had the golden age, no doubt. And I'm a dad, and so that's pretty good too. I have 3 daughters. So we're only going to be talking really about data today. And so to make it easy, and if you're like, oh, I don't know about data, it is really funny. I'll go to conferences like this all the time, and I'll sit around with speakers kind of before the event, and I'll sit around with attendees after the event, and we'll talk about different things. And often I'll say, name the #1 language you think developers should know, right? I love going there. And you could pretty much guess what it's going to be. JavaScript is always in the top, right? Sometimes people say TypeScript instead. And then people will often say Python. C# is in the mix sometimes. Occasionally people joke and say Java. And then from time to time, and very rarely, people will say SQL. And they don't know SQL. Is it an epidemic that engineers don't know SQL? Perhaps. But all that being said, I want to talk about data just conceptually. So I'll talk about the orange. The orange is the data. And just to get it in your mind about how if you were an enormous retailer, if you were a gigantic credit card processing company, if you were a monstrous e-commerce site, then this is the way you would think about data. And so it's really going to be handy. You're going to have this in your pocket as you leave, and you'll be like, this is either how you're going to change the way that your current business is doing it, or you'll just have in your mind the way that large, extremely large companies manage extremely large data sets. And as you go through it, hopefully it feels like common sense. Sometimes people really get backed into a corner sometimes because of the way they handle their data. I do want to say this one last thing, is that when you really look at the large companies, like let's say this is the way Twitter builds their applications. This is the way Amazon handles all of their data. This is the way Microsoft does its architecture. Those are not companies that you should follow. Those are not they can afford enormous architectural mistakes and then recover from them. Instead, you want to look more at companies the size of your actual company and not look at them, because what ends up happening is they will almost aggressively chase bad decisions to see if they can dominate the market by having something novel. And so they will make these weird mistakes, and then they will be on the cover of all the magazines, and then we'll accidentally copy them and put them into our application, and then they'll abandon them just 2 years later, right? And so, like, just remember that just because it comes from a large company doesn't mean that it's necessarily a good pattern for you to follow. All right, let's just begin. We have an orange, delicious, gigantic orange. I would have never have dreamed it'd be so big. That's really nice. And all right, so let's talk about where oranges come from. And so in this case, where your individual data sources are bringing in the oranges for you. So just imagine huge amounts of data. And the way that we work today, even smaller companies still have incredibly high amounts of data. The volume is just really large, and we tend to include even more than we need. And that's okay, because the cost of storage is so low today that we don't even think about it. And so that when we think about the dynamic, explosive growth of data today, it is monstrous. And we're part of the reason, right? Because with data being so inexpensive to store, we just say yes to everything, and we just bring it in. All right, so how do we bring it in? Well, this is just the concept of the data source. The real data source is the line of business application that you're writing. So you write a line of business application, it starts producing the data that you want. That's where it all really comes from. Perhaps you also have IoT systems that do some sort of monitoring. They produce data as well. There's a lot of sources of data, but primarily it's line of business data one way or another, right? It's either your public-facing e-commerce site or your internal whatever site, right? Whatever it is that you have created starts to build out this data, and that's the orchard. Then we get into big data. And so now it starts with you're just picking one piece at a time, and you know exactly what it is. But then a certain number of months pass, or perhaps even years. Perhaps you have 2, 3, or there may be 4 or 5 different line of business applications. And now it's starting to become a little more chaotic. There's nothing wrong with that. That's the reason we have big data. Big data is just that gigantic pile of oranges, and we'll come back to it later. This will be the thing that you can kind of send somebody else off to figure out. And that's the data engineering task that we have in front of us. And it can be handled both manually and automatically. Certainly AI is a big player in this to help us be able to tease out all of the things, all the value. But nonetheless, there it is, super cheap. This is where all you do is just store it into a gigantic blob. Right? You're not thinking really about connecting any of your data just yet. Then we have the initial process. Nobody wants to touch the data when it's filthy. Actually, it's not even good for your business overall from a hygiene point of view, because you start making decisions or start having some insights based on data that's not really reliable. So instead, now you go through an initial process where you involve either the stakeholders or some sort of business unit that understands the data. The problem is they never have enough time to really go through the data and explain it in a crisp way. But from time to time they will, and that will be the entire effort, right? For the year 2025 until 2026, we're doing a data cleanup project. And that seems like some sort of monotonous project, which it absolutely is, but it's also one of the most valuable, because on the other end of that project, you've taken all the data that was really untouchable, and you've made it so at least we have an idea of how to use it. All right, so this is just the ETL process. E for extract, L for load, and T for you don't know the D in the enterprise, but you know the T. Are these nerds? All right, so you're right, it's T for transform. Finally, we get to the idea of data warehouse. Now we've taken our oranges that are nice and clean, and we put them into boxes, and things are organized in a slight way, but not much, not really. And so we have it all laid out. We put it where it can be stored, taken care of, it's protected, and we would think about this from a data point of view of putting some sort of security around it in a very manageable way. Also, protecting the cleanup work that we've already gone through. We may not be able to consume it yet, but at least we have the idea of where everything is going to be. Then we go to the next step. So this is the data warehouse, very handy, somewhat unusable, I mean, to be honest. And so we take everything down and we try and squeeze it into something that's actually usable for the user. And so we take it and we create a data mart. And it's funny because data marts have kind of come in and they've gone out of popularity. It's really funny. They're kind of trendy, not trendy at the same time. Data marts are super handy. They'll take an enormous data warehouse, they'll pare it down to something that's extremely small and make it so it is tailored towards a certain group, making it so it's very, very useful. So in this case, we make some orange juice out of it, right? It's really nice. It's only one thing of orange juice, and that's meant for you. And it's not meant for me, right? Because I might want it another way, and that's important. You might have many, 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 many data marts, and that's because you need to consume the data in different ways depending on what your business case is. Sometimes you do need just orange juice, and sometimes you need little candied fruits and whatever. But the whole point of it is they are all sourced from the same data warehouse. Now, sometimes we don't have time to build a data mart. Sometimes data marts are just, we feel like they're just not trendy enough for us. So we're like, now we have self-service BI. So now we drop a pivot table on top of it, and we say, look, you can answer your own questions. You can answer questions that I didn't even realize that you wanted to ask when you first did it. And all you have to do is do it this way. Sometimes these are pre-compiled cubes that are already ready, and all the data is like prepared, and computation is already done. Sometimes it's on the fly. It totally depends on the way that you do data. And neither is wrong. I think that's a really important part to take away here, is that there are really two ways to think about this. We cater to the user and we give them exactly what they need, or we do not. Well, I don't want to say we don't cater to the user, but we raise the expectations for the user and we say it's going to be self-service BI for you, and you're going to be doing your own pivots and whatever. All of those are right, depending on what your business model is. And it's really frustrating because I can tell you that in my line of work, I meet a lot of customers that all do data, and they value data just like you do. And when they do it, they are very dogmatic. They feel like the way that they're doing it is probably the only way that actually makes sense, and everybody else they see is frustrating to them. What's frustrating to me is to feel like there's only one way to do the same thing when there are so many ways and so many of them are supported so well. So I'll say all this to say, it just depends. It depends on the way that you want to run your business. All right, so that's self-service BI. Now we have the new world, right? So where oranges aren't even the thing anymore. Now we're going to do something that you never dreamed was in there. And what's even more incredible about that is I didn't even realize that the thing inside the orange is that we had always removed is one of the most valuable things in the business, and somehow you were able to use that to find something brand new, right? It's very exciting. And so no doubt about it, the data science world has been able to transform this latent loss of data that we have inside our enterprise, where we have so much data and we realize that about 20% of it is useful, but it turns out the other 80% is insanely useful. Or the opposite. We thought 80% was useful and 20% was throwaway, but that 20% has the signals that tells us how to run our business in a more effective way. It's really incredible. All right, so that's at the high level. Now let's talk from a more of a practical sense of the way that a real company would manage it. So now that we've kind of gone through what data is and each of the components and all the language around it, here's how you would do it typically in a larger business where you have a lot of data that you have to deal with. So you would use the medallion strategy. Out of curiosity, has anyone ever heard of the medallion strategy? All right, I would say about a quarter of you. That's actually very high. I'm impressed. And I don't mean impressed. It's unusual. The medallion strategy is right for a lot of companies, but it's not right for every company. That is absolutely true. However, I would say it is probably right for a majority of companies. And the medallion strategy is this. The idea is these are the medals from the Olympics, 2020 Olympics, and gold, silver, and bronze. So they're not in order. It's silver, gold, and bronze, but that's the way you would stand on the stage when you're receiving your medal. That's why they're in that order. But the idea of the medallion strategy is we create different places inside our organization where data goes. And the first one would be bronze, and then we go into silver and gold. And I'll explain that here in just a second. One thing I do want to point out, just because it's sort of fun, is that this was in Tokyo, 2020. And one cool thing that happened was it was the very first time that two Olympians agreed to share the gold medal. So two pole vaulters were both jumping, and they reached a certain height, and it was a tie. They both jumped multiple times to try and beat each other. And finally, when they realized that they couldn't jump, they were just struggling, they agreed to share the gold. Well, isn't that just the way the world should be? No doubt. And here they are. Look how happy everybody is. It's terrific. It has nothing to do with data, by the way. Just a moment of pleasure. That's for you. There you go. All right. Let's talk about it from the bottom to the top. So we start with the bronze layer, which we might call a data lake, which we might call just the raw layer sometimes. It might just be called a dumpster, and it is where your application takes all of its data like a dump truck backing up and just dumps it in there. Doesn't pay any attention to whether or not the keys have surrogate keys or not. Doesn't pay any attention to whether or not the dimensions are normalized. Doesn't care about date format, nothing at all. Nothing is paid attention to. We're just taking almost a backup and restoring it into the lake. And often this is stored as a blob. Sometimes it's just a simple file, and it's not organized, it's barely structured, and everything is the way you want it to be. This, by the way, if you have multiple line of business applications inside your business, and you are able to convince the application owner to take their data and on a regular cadence, sometimes that cadence is quarterly, frankly, sometimes it's monthly. It is never weekly, but let's pretend it's weekly sometimes. Daily is a dream come true, right, if you're lucky. Because you have to think whoever owns that application also owns the responsibility of how performant it is or isn't, how responsive it is, and they care a lot less about your reports than they care about their application. And so they will always push back and make it so that they're providing the data into your lake at a rate that matches their needs, far different than your needs. That becomes really difficult, especially if your manager has said something crazy like, I need real-time data. Now, real-time data is code for, I need really, really expensive data. And it is never going, well, I don't want to say never. NASDAQ certainly has real-time data. There's no doubt about it. If you go to Visa, their data is real-time. Absolutely it is. However, once you take off the 0.001% of companies that need real-time data, it drops to zero. Like the number of people who truly have we just need a new term. And that term should be near time. We need near time data. And what does near mean to you? Every company is going to be different. Near means 24 hours. Near means 1 week is totally fine. As long as it's reliable, that's near enough for me. That's really nice because that takes a lot of commas off the price tag of what it takes to get your data into one place. And remember, the application owner who is providing data to you will only provide data to you at the rate that they can afford it for their application, regardless of what your near-time or real-time requirements are. So it's this constant, it's not a battle, right? It's just this negotiation between all the people in your organization. That is the raw. Now, once you have bronze in place, obviously silver is next. But let me say one more thing about bronze. If you have a data lake that is like this, bronze, and your data is actually in it in some regular cadence, hallelujah. Like you have already beaten 90% of all the companies out there. It's incredible. To be able to unify your data, absolutely amazing. Now we can graduate into the next phase where we already have that data, and thank you for letting us be in the top 20% of all the companies, but now we'd like to be even better. So that brings us to silver. Silver is the curated level. Is the cleansed level. So this is really difficult to do. And the reason it's difficult to do is because usually the way that an application stores or constructs its data is unique to another application. And so what you need to try to do is make it so that all of the, in the United States, for example, we remove social security numbers. So whatever the PII is that's in there is going to be cleansed and moved out to make it so that people can query it more casually and they don't always have to have really high levels of security. We'll also make it so all of our dimensions now have been conformed to one another so that the way that you store dates in one application is exactly the way you store dates in another. Remember, you're not changing the application, you're just massaging the data as it moves from one location to another. And I mean moves. So you will have it in a stored location that is your bronze location, that is your lake, right? Very inexpensive and easy to use. And then you'll have another, and you're like, aren't I duplicating the data? You are absolutely duplicating the data. That's what you want to do. And as it moves over, you put the T, that's the transform in ETL, and you make it so that it is slightly cleansed. Now, you're not making it perfect, but you are making it better, and you're making it so that anybody interacting with the data has fewer questions in their mind about how things work, right? When they go in, they're like, what's this weird table? Well, when it's cleansed, it's at least given proper names. It's at least given all the formats that make it useful, and you take things away like M and F, and you make it male and female, right? Things like that are expanded so that the reports are easier to write. And then finally, we end up going to the gold layer. The gold layer is the curated layer. Now, the gold layer is usually where we see the introduction of surrogate keys. It's where we make it so that our applications that have, so a surrogate key is basically saying that the application has a key, and this other application has a key, and they actually should relate to one another, but they don't because they were built in two different systems. And so we'll create a surrogate key on top of that that will actually allow them to relate. So I can use that surrogate key to drill down into each of them. What that allows you to do is to write some sort of report or write some sort of query into your data that joins across multiple systems. So we've already gone into silver so that when I write those queries, I don't have to add all the bulk and like nonsense of making it so it's easy to use. And then as I go into gold, it's actually more beautiful, so I can have all of my applications talking to one another, and I can start to investigate things across the entire enterprise rather than isolating them into the silos of the individual departments. All right, so that's bronze, silver, and gold. What you should know is that bronze is spectacular. If you get there, you have already crossed a threshold that is very difficult for most companies to cross. Getting to silver is unlikely. I wouldn't even make it a goal. I would say someday maybe, make it a stretch goal perhaps, that maybe you'll get into a place where we have this, all of our data is at least cleansed to a point where I would be able to write a query against it and it wouldn't be a bunch of question marks because I would understand what it is. Getting to a point where you have surrogate keys across your entire enterprise and everything interacts the way you would want it to be, and we have, that would also include things like data dictionaries and all of the security across it to make sure that it's secure for everybody. That is, gold is very, 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 very difficult. I meant to say very, very, very difficult. It is very difficult. And it is so unlikely that you'll get to gold that I hate to even bring it up because it makes it sound like that's where everybody should be. But the cost of getting to gold, the likelihood of getting to gold, the time required, and the amount of labor in order to get to gold is completely worth it, but is unlikely you'll get there, right? I mean, if we weren't working with people, I think we can all agree the worst part of software is users, and there's no doubt. And the worst part of data is the same thing, right? It's these users, and they're never available, they're never clear enough, all of the other things that are there. Then you finally get to gold. Let's pretend Nirvana has arrived and you're in heaven together, and somebody changes the schema of your stupid line of business application, and you have to go all the way back into bronze and figure out how to get it back in there. You're like, well, it's only going to be a 2-year data project, and we'll be back to Nirvana again. And nothing will change until then, I'm sure. All right, so that's the reason I want to say there's just a reality that gold is difficult. All right, let me just say this. The largest brewery in the world, this is how they manage their data. The largest insurance company in the world, who I have, these are all my customers, this is how they manage their data. The top 2 largest airlines in the world, this is how they manage their data. The largest law enforcement agency in the United States, this is how they manage their data. The largest grocery store, the top 2 largest grocery stores in America, this is how they manage their data. And this is how Microsoft manages their data too. The goofy little monitor is supposed to be Microsoft. I didn't want to name any names, but I can at least name us. A very large software company also manages their data this way. What I can say about it is none of them have gold. Right? So just have it in mind. They all have the vision of gold. They all talk about gold to their stakeholders and to their stockholders, but the reality of gold is so elusive that I just want you to have that in your mind, that is where we want to go. That is actually the best way to use our data. It is the least likely thing that you're going to accomplish. So if you do it, by the way, wow, that just is incredible. Let me say it that way. Okay, as you're building any ETL process inside your application or inside your enterprise, I can tell you, as one engineer to another, what you will be tempted to do. You will be tempted to open up Databricks, to create a notebook, and to write the transformation inside your notebook. And then you will remember that you have something else that you need to transform, and you open up a brand new notebook, and you will write the transformation, and you will save that notebook as well, and it will work beautifully because you will create a job. And then that job will be managed by a higher notebook that lists the notebook so that you can run just one notebook that calls those notebooks. And when you need to transform something else, you'll add another notebook. And then when your boss comes to you and asks you where it's all logged, you will go back to all three of those notebooks and you will add logging. And then when you need to transform something else, you'll add, and it is irresistible for us as engineers not to do it this way. And I just want to say that you don't have to use Azure Data Factory, but don't write it yourself. It will be so tempting to write it yourself and make it so that all the transformations are right there. And you're like, why would I use a tool that's so complicated when I could just write my notebook? But that notebook will inevitably evolve and become more and more sophisticated and less likely to be manageable. And then we have to worry about the axe murderer. The axe murderer is the developer who replaces you. He's the maintenance developer, and he's always in a bad mood, and he knows your home address, and there's no reason to make him mad because you have done it right. You've used a tool that is reusable. You've used a tool that is clean and logging and secure and all of the things like that. It is not a hodgepodge of things that you've put together. One engineer to another. Let me just say, we all do it. You will open up Databricks, and you'll be like, why wouldn't I just? We all do it. All right, just try to use a tool if you can. ETL on the enterprise scale gets messy really fast. All right. This is the way it looks, by the way. You'll have 3 line of business applications going from gold, silver to bronze. From bronze, silver to gold. But the reality is, perhaps you'll be in a situation more like this, where one of your applications goes into bronze, one of your applications goes into silver, and if you're lucky, one of your applications goes into gold. You can't think about it as the entire enterprise moving from level to level because that's very unrealistic. You might be able to touch on gold, and that might be really valuable because this one line of business system that you're using is actually the one that your executives use to build their dashboard or whatever. That's very reasonable. So having a situation like this is more likely than having a situation like this. This just is not, does anybody have a situation at all similar to this? Nobody's raising their hand. I'll pause for a moment in case you didn't. Okay, it's just not, it's impractical. All right. Although it's the dream. You never want to give it up. I know I keep kind of dancing back and forth on this line, making it sound like this is what you should do, but don't expect to ever do it, right? I want you to just remember. One of the reasons it's so difficult, but one of the reasons it's so important is that there is security at every tier. Every single time you move from each one, you must secure it. There's no doubt that you can look at this dumpster of your data lake and you're like, that was so easy. But it's not done until it's secure. If it's not secure, it means people can muddle around in there and get into whatever they want, and that's not what you want to do. You have to do it one way or another. You are either going to take your application and the entire block of data, and you'll secure it to a group of people, and you'll take another application, and you'll secure that to another. Or you'll actually go in and you'll remove things that should be removed, like PII data and things like that. And you're like, now I can expand the breadth of who has access to that data so it's a little bit better. One way or another maybe you'll use Purview or some tool like that. That's an enterprise data dictionary that allows you to overlay full security on top of it. That could actually make it hard to even get to a bronze layer, but it makes it so that the bronze layer is still much more valuable, even though it hasn't been cleansed like silver. But what we can't do is make it so that security is omitted from any of the tiers, right? It must be part of all the tiers. The other is the idea of storage in everyone. Where it's stored and how fast it is really does matter, right? I'm going to look at my application, and I'm going to look at my data lake, and I'm going to say this is where it stops. We may never get past a data lake, and terrific. That data lake needs to be accessible, and it needs to be fast, and it needs to be secure. You need to treat it almost like silver, even though it's bronze. That's because you have made the decision that that might be where it stops. So we have to think about storage. The cost of storage, by the way, isn't the issue. It is the size of storage. Regardless of the technology and libraries that you choose, regardless if you're on AWS or Azure, it turns out the speed of light is exactly the same in both cases. And so moving electrons can only move as fast as electrons can actually move. And so even though you have all of this data and you want to do a quick copy over, time is going to happen. Time is going to be taken as it's copied over. There is no snap and you've got a copy of it. That just doesn't happen. So that's another thing to consider, is the overall size of it, because each of those impacts the timing of each tier. All right. One other thing to think about is the engineering that you'll need on every level. Now, at the bronze, if you're realistic with yourself, you might think to yourself that I'm going to stop at bronze, so there actually will be some engineering. I can't really do what Jerry was saying, where he backs up a dump truck and he just dumps it in there. But instead, he backs up a dump truck, we tidy a few things up, then he dumps it in there. That's really nice. All right, so we have engineering on each side. And then finally, just to understand that there's going to be this delay. So back to the speed of light. The speed of light is the same both in Norway and the United States, both in AWS and in Azure, both on-prem and in the cloud. Nobody has a shortcut to the speed of light. So as you copy data from one place to another, especially when there's a lot of it, there's some amount of time is going to be taken. When you introduce then security, some more time is going to be taken. And then as you introduce some sort of engineering to it as well, so you do some transformations, a smaller amount of time is still going to be taken. Overall, the idea of real time is going to be impossible if you take the medallion strategy for your company. Don't take the medallion strategy for your company and you won't have a plan. You can see the yin and the yang here. And so the balance is really hard when you're trying to think of how to solve the problem of real time. The best you can do, by the way, if real time really were to be one of the things that you were measured by and you must deliver it, is to make it so that you have the medallion strategy for all of your data, and then for a thin slice of your data that needs to be real time, that's the one you allow to skip some of these processes so that they can be more real time, right? It's very difficult to get the real time and ensure that it is properly secure and engineered. Not impossible. All right, so just a quick summary of the ideas here. The quality in each section is going to be different. The quality in bronze actually, obviously is going to be raw, and the most beautiful is going to be gold. Whether or not it's enriched or not is going to be up to you, but generally, there's no enriching in the bronze layer, and as you go into, and let's just pretend that something that makes your data really valuable is to make it so that it is includes the weather, all right, let's just say, right? So that would be a type of enriching. Or perhaps you have text fields, then you'd like to include vector embeddings in those as well that you get from like an OpenAI embedding model, right? That would be a type of enriching your data as well. So you might do that in silver, but more likely you would do that in gold, right? Not impossible to do it in bronze, but that would be very unusual. Which is the most reliable? The bronze is not all of that reliable, and partly the reason that it's not is because the data there hasn't been touched yet, right? And so it's really relying on you to figure it out. And so it's more like a puzzle that you have to figure out. Instead of just relying on the data that's there is the data that you want to use. And then finally, the delay, we talked about the delay, the longest is going to be the best. And so if you only want to give your executives access to the gold layer because that's the way you want them to really be able to see it, rely on it, and understand it, you're almost immediately saying, and the executives will never have the real-time data, right? It's bizarre how these things kind of balance to each other. All right, that is the medallion strategy. So we talked just conceptually about the oranges and where all of the data came from, and then this is the medallion strategy. Now let's switch to developer talk together. And if you are on an engineering team or a data engineering team, often those aren't separated anymore. It's very rare to find a team that's only for data engineering rather than just an engineering team that's responsible for data. Which means that if you don't know how to write SQL, it's difficult to do, but it's not impossible because we have all of our AI friends now making us capable of doing things we've never been able to do before. But I will say, if you've ever used Copilot or any AI to help you write code and you're like, well, it's pretty good, but there are some problems, try having it write SQL for you and then try and debug that. It is a frustrating situation. We are releasing, by the way, SQL Copilot, which is going to be trained on your data and schema and be able to help you. But I think we're several years away from where you can actually take a query created by any AI and execute it with your eyes closed. Right? I think it's impossible to even consider today. All right, so just a couple of tips that are kind of fun for us as kind of nerds together. One is, if you don't already know that we have WinGit support for SSMS, then this is pretty handy. The fastest, easiest way to install SQL or any of the tools that Microsoft makes today is all through WinGit. If you've never used WinGit, it's kind of like chocolatey, right? But it's built into Windows is the difference. Pretty handy. Won't spend too much time on it, but I wanted you to know it was there because certainly it's the way I install SQL today. The other is if you're not using polyglot notebooks. So polyglot notebooks are part of VS Code. They're not part of. They're an extension you add to VS Code. They're part of the .NET Interactive team. It supports, there's about 7 languages or kernels that it supports. One of them for sure is SQL, but also C#. So because I'm also a professor of C#, I love polyglot notebooks. It's a great way to get things to get done. I won't spend too much time on that because I don't want this to be the main thing, but I want you to see it and just know that it's there. The other is the MS SQL extension inside Visual Studio Code is completely rewritten. It is a spectacular new extension for interacting with the data, interacting with your data. And from this is a handy tool for you developers to have, is absolutely the tip. It is one of these things that, well, I'll show you some of the capabilities. So one of them is that it has a query editor, and the query editor interacts with Copilot, so it's really a great way to kind of do initial work. Even before we have SQL Copilot released. So this is just using your regular Copilot based on the workspace context that it has. But I'll show you in just a minute the SQL database project and how it gives it more context so that the Copilot gives you a better recommendation as it's giving you kind of query tips. And it has a table designer, which is great. If you don't use SSMS today, or depending on how you interact with your database, then this will make it a lot easier for engineers or developers who maybe aren't familiar with all the syntax of interacting with a database, but they still want to get it right. So you can use the designer to do it as well. But added to the extension now is SQL Compare. And the reason this matters is because the SQL Compare is actually built into database projects, and database projects will enable you, well, I'll show you in just a second, but that it's the schema designer is part of the schema comparer, and the schema comparer is part of the database project. It's beautiful. So this is still in preview right now. You can drag and drop, move things around like you would hope to. It's a great way to be able to communicate with your colleagues all the different parts of your database in the way that you would expect. It's a little bit like Draw.io or the 5 million other variants on the web. It's kind of crazy how many, like even Mermaid now has an editor. It's just crazy, all the things that you can do. So we also have one. It's because we joined the party. It's terrific. And it is native to SQL now, and it interacts with all of your backend tables, shows them as a live schema rather than a theoretical schema, but it does allow you to change it locally and then publish or commit those into the database. It writes the update script for you, so it's very cool. All right, so there you go. And well, the schema compare is where we really start to see a new way of interacting with our database itself. So let me start by saying the schema compare will do 2 things. It will compare both the schema of your database, and it has the ability to compare the data of your database as well. Obviously, if you have an extremely large database, that's going to be very painful. But if you have a modest database, that's really nice, especially in a development environment where you might want to be able to move development data from one system to another. That scenario of having a development database is actually pretty complex, and that's where database projects come in. So database projects they are the opposite of code-first data. So if you're an entity framework developer today, you would be a code-first developer, is what we would call you, right? You would create a POCO object, you would mark on it, and you would decorate with some sort of attribute what the key is, where the indexes are, other things, right? Whatever the max length of your string is, all of these things would be decorated inside your inside your class, right? Your individual DTO, and then you would migrate that into your database. It would transform your database into whatever structure you had inside your app. That's really handy. That's code first. Here's the problem with code first. This will be very controversial, but it's just reality. If you have, let's say you have 30 POCO objects so that you can manage your application, and all of those then will be migrated into your database, and they will become tables the way you would want them to. But your database is different than your application. Your application, with its 30 POCO objects, every time you migrate, those tables get updated. But your database has 150 tables in it. Those 150 tables are required for a lot of things. It's where you store your embeddings. It's where you bring in enrichment data. It's the way that you maybe migrate from your CRM system. Maybe it's just reports and denormalized tables. Where does the schema for those get managed? Where does the schema for those get handled? Not in POCO objects inside your code first. And that's the fundamental issue with any kind of code first approach to data, is that you aren't able to effectively manage everything inside your application, inside your database, right? It gives you kind of the wrong feeling. It is terrific if you're creating a proof of concept and you need something done by this afternoon. It is absolutely the way to do it. However, in the long term, data first or code first to manage your database is going to be a struggle after you graduate into some sort of enterprise scenario. That's the real issue. And if you're using if you're using Entity Framework today and you love code first, go for it. No big deal. I would guess you already know what I'm talking about, though, that you hit this wall of maintainability. All right, so, let me back up. So the other issue is being able to put your schema inside your source control so that it can be managed and go through a PR process just like you do today with all of the code that you write needs to be part of the schema as well. Most developers, I'm sad to say, is still true 20 years later, simply opens up the editor inside the database and just starts typing the stored procedures, typing the view, typing whatever it is, and then they do maybe a big diff at the end of some release cycle, and then they push that into UAT and then into production. That's a normal process, but it is a painful process, and it is also a very unstable process if things start going wrong, because there's no management inside a database to be able to handle the same sort of quality that you have in a CI/CD pipeline and inside regular source code management. So in order to solve that, we have database projects. This is a database project inside Visual Studio Code. It's also inside Visual Studio. It allows you basically to have a regular SDK project that is part of a build process that allows you, or in this case me, to go in and create a table. So you can see I have a single table inside well, let me put, it's really strange. It's so high. I can't point correctly. But well, I'm still not pointing. I realize I'm pointing on my screen, not yours. I have this cool laser. So there it is, right there, the table column right there, or folder. So you create a folder, and you structure it just like you do your ordinary source code, and you put SQL files inside it, and they're just the creation scripts. You never have to think about migration scripts or update scripts or anything like that. You don't modify. Instead, this is all about creating the schema the way that you want it to be created, and then you allow the system to find the difference between the two and create the update script for you. It's really awesome. And the other thing you can do, and I think so in seed data, for example, this would be the script that would execute after it's published, so that if I need to create, and in fact, let me show you this real quick. I am going to let me break script here just a second and show you something cool. All right, so this, if I were to create a brand new SQL project or a database project, right? And it goes to every flavor of SQL that exists. I could say whether or not it wants to be on SQL or not. And let's see, my DB, great, and I'll put it perfect and perfect. Oh wait, sorry, I'm just putting it in a folder. That's all I'm doing. I don't want to make. And here I'm just saying, do you want it to be SDK style? And you just say yes to all the. It's just next. So now it's empty. There's no tables. There's no stored procedures. There's no views. There's no data. There's nothing. And I would say create a brand new table. And so let me add a quick table just real quick right here. Add an item, and I'll pick that it wants to be a table, and I'll call it users, let's say, and with a single column. All right, so there's my user table. When I am ready with this project and I have all the different relationships and everything structured the way that I might want it to be, which is far superior than code first because it allows me to use things like Schema Designer, but it also allows me to do things like all the other table store procedures and views that I have, the triggers and all the things designed inside my database managed in a single place. Code first doesn't allow me to do that, right? That's the downside. So as soon as you start, like, I want to take advantage of these database capabilities, but you can't because they're not part of the code first schemas. And so instead, you're like, well, I need to do it this other way. Now you have two ways of doing the same thing, and how are you going to be able to bring those together and know that they work together? So right now, I can right-click, and I can say build, and it'll build just like a C# application would, and it'll tell me if anything is wrong with my code. That's nice. The next thing I can do is I can add a view over this that points to it. And if I need to change the table so that it has a different column name, I can do a semantic refactoring just like I do in C#, so that if I change it here, all my stored procedures that reference that, all of the views that reference that, or tables that reference that, they also get updated as well because it's built into the database project. And on I go. And so I can build it again and see if everything is working, which means that if you hand this off to your engineering team and they give you back a database project, you can put it inside your CI/CD pipeline and say, first, does it build? Second, can I do analysis against it? Because just like we have analyzers for C#, we have analyzers for SQL, and so now you can run analyzers against it to make sure that best practices are being followed. Then you can deploy it, and this is the part I wanted to show you, where I can right-click it, and I can say publish, and when I publish, I can deploy it right to a container, because SQL runs in a container, right? So it's because it's Linux-based now. And so I can run it inside a container, a tiny little container inside my CI/CD pipeline, and it makes it so that everything can be inside a tight little process that you can manage and control and trust. Unlike when I do it directly inside the database, there is no process, and there's no way you can trust it because things can go wrong. If I write a stored procedure that references a column that doesn't exist, I get an error. But if I write it and it does exist and I save it and then I change that table, the stored procedure doesn't break, right? So now I have this like disconnect inside my database that has gone terribly wrong, and we've all suffered from it because we've done it the wrong way many times. But if you do it inside a project like this, all of a sudden we have this interconnected way of making sure that the entire process can verify itself. Right, it's really nice. If you haven't used database projects, well, you're missing out because they're super duper, and that's just the way it goes. All right, in the last minute, I want to talk about my favorite thing by skipping. You can target Brad. Well, let me just say this real quick before I skip past this. The normal dev process allows you to first hit against all of the rules that you might have that inside your application. Those are the analyzers for your data. Remember, we're talking about data engineering right now. So you would be able to run the same sort of analyzers that you would run today that you run to lint or analyze your C# applications. So that before it even goes in your pipeline, it has to have this, let's say, PR gate before it's even allowed to be committed into your main repository. Then we can deploy it into a container, which means now I can run a unit test. So just like, can you imagine writing a method in C# or in whatever language and not writing a unit test and saying it is 100% engineering ready? No, you must test things in order to know that they're really there. That helps you find regressions, and on we go. Now, we all have moments when we don't write unit tests. I don't mean that. I just mean it's really, really done. It's because it's fully tested. A store procedure is the fastest way to interact with data in a database. There's no getting around it. If you think that bringing the data out and then massaging it inside your language and then passing it back, it is never going to be as fast as when you're sitting in it. A store procedure is a method. Can you imagine a method that is never tested? So if you don't have a part of your process that unit tests at least your store procedures, you're actually very incomplete. Right? You should never think of it as engineering complete until it's fully tested. And if you're not testing your stored procedures with known data so that you can create an empty database, put in known data, execute, and look for the known values returned, then you're not really engineering complete on your stored procedures. That's an important part of any data engineering process, and that should be part of your pipeline as well. All right, last thing I just want to point out is when you're interacting with the database, by the way, that's the new SQL Server logo. Groovy, right? As of this week. All right, so if you're interacting with your database, you should always use some sort of data API layer. You shouldn't talk directly against your database. You should talk against your data API layer. And if you're going to have a data API layer by either writing a minimal API or controllers or something in ASP.NET Core or whatever it is you use, good. That's the right way to do it. The even better way to do it is with Data API Builder. If your backend database is Postgres, Cosmos DB, MySQL, or SQL Server, then, and if you're on-prem or in the cloud, it doesn't matter, you should be using Data API Builder to be able to take all the code that you're wanting to introduce into your code base and just remove it. You don't have to write unit tests against it. You don't have to put it in your CI/CD pipeline. It's just your Data API built for you dynamically based on the structure of your database. This is the way. This is the way. It is, you will have 100% of all of the code that you need for your data API, remove down to 10% remaining. And that last 10% will be some special business process that differentiates your app from everybody else's. That's still important. But the CRUD operations against your database need to be replaced by some sort of data API. And why write the code when we have Data API Builder that has no license, it's free, it's open source, you should be using it. The fact that you're not is crazy. Out of curiosity, has anybody ever heard of Data API Builder? Oh, great, wow, that's, all right, cool. A handful of you have. That's great. And so Microsoft is the main contributor to it. It is open source, and it's at least worth kind of thinking about because many of the features that you would have inside your data API that you would go and instruct your engineering team to write have already been written for you. And it's all open source. Look at the code. There's nothing exotic. We wrote it the same way you would write it. And the missing feature that you really, really need is just one PR away, and you can just offer it to us, and we'll bring it in. So it's one of those things where it is the backbone of Microsoft Fabric, and soon to be in other tools as well. So just think about that as things go along. All right, so I think in my last second, I'll just point out that there also is a Visual Studio extension for Data API Builder called Omnibus. And if you haven't seen it, then this is a great way to get started because you can right-click and say init, and you can have it running in moments. And so it's a very powerful way to get started. And that's the entirety of it. Thank you for listening. I feel like there was a lot of information, and thank you for the feedback. I mean, it's funny because it's difficult to see you guys, but you are vigorously nodding, and I appreciate it. So thank you very much.